as well?
Yes.
Thank you. 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, 377, 610. This sequence of numbers appears to have absolutely no significance whatsoever on any area of life, except for maybe my math class. In fact, right now you're probably a little bit concerned that for the next 10 minutes I'm going to be rambling about this sequence, or talking monotonously about various sequences and their formulas and their relations to the variable n as it approaches infinity, and just boring you to tears with a speech on mathematics. But the truth is that the specific sequence of numbers that I listed at the beginning of the speech not only carries heavy significance in my math class, but it also is the basis for the building blocks of our nature, the anatomy of beauty all around us. These numbers point to the glory of our designer, our creator, our king, and our God. Today we're going to be looking at mathematics and its relation to nature. See, we live in a wonderful and beautiful world. Simply walk out into the streets of my hometown of Colorado Springs, you can't help but be overcome by the majesty of the beautiful snow-capped mountain range before you. There's just something amazing about a simple snowflake, the intricate designs and the symmetry of an arrangement of molecules smaller than the tip of your finger. There's just something amazing about the spring flowers and the petals and the intricate designs on each of those individual petals. We're going to be looking at some of those intricacies today. See, the purpose of this speech today is to boggle your mind by showing you similarities and patterns throughout nature, relating mathematics to beauty around us. So we're going to look at this through 2 points. First, we're going to look at mathematics and its relation to beauty and nature. And secondly, we'll look at how this all ties into the origin of our world. So let's start off by looking at the various mathematical intricacies of nature all around us. See, Albert Einstein once said that it is mathematics that gives the exact natural sciences a certain measure of security which, without mathematics, they could never attain. Albert Einstein is a really smart guy. What he's saying there is mathematics and natural sciences are directly related. You can't separate the two. Nature and natural sciences depend on mathematics because nature and its design is very mathematical. We're going to be exploring some of those intricacies today. But see, even with the beauty around us, even with the beautiful snow-capped mountain range right outside, we have people that believe that we're all here by chance, that this beauty is accidental. But the truth is that Pikes Peak doesn't take your breath away by happenstance. No, this beauty is absolute. It is designed, it is intricate, and it is mathematical. There's order to it. Let's talk about some of those mathematical intricacies. One in particular is the presence of fractals in nature. Now you're probably wondering what a fractal is. Well, Princeton University defines a fractal as a geometric pattern that repeats itself at every scale. And now you're probably wondering what a geometric pattern that repeats itself at every scale is. Well, the best way that I can think of illustrating it is by the Star of David fractal. You're probably familiar with the Star of David, but just in case you're not, this is how it works. Equilateral, equiangular triangle drawn on a piece of paper. Just same sides, same length sides, and same measurements for the angles. We draw that on a piece of paper right side up, and then we take the same dimensions for that triangle, we flip it over, and we put it on top of the right side up triangle. You've just created a 6-point Star of David, and each of those 6 points is represented by a smaller equilateral, equiangular triangle. Now, if I take each of those smaller 6 triangles and I repeat that process right side up over upside down, or upside down over right side up at every scale, creating a new fractal design on every pattern, I'm creating the Star of David fractal. And coincidentally, or not so coincidentally in this case, that specific fractal resembles a snowflake. Snowflakes have fractal designs. Anybody who's gotten the chance to look at a snowflake up close has marveled at its fractal design, its fractal intricacy. Smaller patterns branch out from bigger patterns, which branch out from even bigger patterns, which branch out from even bigger patterns, creating this beautiful symmetrical array of tiny little atoms and molecules smaller than the tip of your finger. That right there is amazing. But it doesn't stop there. WebEcoist.com did a study on the presence of fractals in nature. From the terrifying zings and zaps of a lightning bolt, to the lively stems and branches of a fractal fern leaf, to broccoli, to cauliflower, to stalagmites and stalactites, the aerial view of a coastal line or a mountain range, they all have fractal consistencies or fractal patterns within them. See, there's geometry and order and structure behind nature. They've also seen fractal designs in animals such as peacocks and sea urchins and starfishes. This is fascinating to me. We appreciate this beauty, but we don't appreciate the design behind it so often. We see the beautiful creation outside and we just take it for granted. but there's such order and such complexity behind it all. Now, what about those numbers I mentioned at the beginning of the speech? 0, 1, 1, 2, 3, 5, 8, 13, 21, I could go on and on and on. What do those numbers have to do with nature? Well, those numbers are part of what's called the Fibonacci sequence. According to the University of Surrey, Leonardo Fibonacci was a 12th century mathematician who originated this sequence, and here's how it works. Any number in the sequence is equal to the sum of the previous two numbers. So let's take 8 for an example. 8 is preceded by 3 and 5. 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21, so on and so forth. You take the previous two numbers, add them together, and you get the next number. If you're a math nerd, I'll provide the following explicit formula. F of n is equal to f of n minus 1 plus f of n minus 2, such that n is greater than 3, and f of 1, 2, and 3 are equal to 0, 1, and 1. Does your brain hurt? A little bit confused right now? If so, I'm accomplishing my goal. I told you the purpose of the speech is to boggle your mind by showing you how complex nature is around us. But I still haven't told you how the Fibonacci numbers relate to mathematics. Here's where it gets interesting. The Fibonacci sequences have been analyzed and dissected in every way you could possibly imagine. They've attached it to Pascal's triangle, showing various sums, adding up to the Fibonacci numbers in terms of the diagonals on Pascal's triangle. None of that is really interesting to me. What's really interesting to me is the Fibonacci spiral. The Fibonacci spiral is created with an arrangement of squares. Now, each of those squares, obviously, each square has equal length sides. Those lengths are all based on the Fibonacci numbers. So you have two lengths of 1 unit, and then 2 units, 3 units, 5 units, 8 units, 13, and they extend in an outward circular pattern. Now, if I am able to take that arrangement of squares and create a line or a curve connecting the diagonals of each of those squares in an outward fashion, I'm creating the Fibonacci spiral. Just talking about it, it sounds like an ordinary spiral that has nothing to do with nature, but the interesting, unique attribute of the Fibonacci spiral is that it extends outward as it goes, as the numbers get bigger. And the interesting thing about the Fibonacci spiral, it is the exact same spiral that you will see on a seashell at the seashore or on the back of a snail. Who would think that just a simple little snail trudging along the sidewalk or a little beach rock that we step over all the time would have a math sentence behind it like 0, 1, 1, 2, 3, 5, 8, 13. That's fascinating to me that it has such order and design. But it doesn't stop at the seashell and the snail shell. The University of Georgia did a study on Fibonacci numbers in nature and found that there's Fibonacci patterns and Fibonacci sequences in some way or another in the growth buds on trees, the rows of pine cones, the gaps and crevices of an artichoke or a pineapple or a lemon or an apple or a chili pepper. It's amazing how many different things in nature have this design, have this mathematical sentence behind it. And I could go on and on about the different mathematical intricacies of nature. But now you're probably wondering what this all has to do with the origin of our world. See, if you put it into perspective with our culture, a culture that believes we're here by chance and believes that beauty is accidental, it starts to make a lot of sense. I know you don't usually think of a lemon as beautiful, but the next time you get your hands on a lemon, go ahead and cut it open and look at that lemon and tell me that that lemon could have existed by chance. Marvel at its complexities, marvel at the gaps and crevices, marvel at its symmetry, marvel at how neatly designed that lemon is. And then if you're convinced somehow that that lemon exists by chance, put the lemon down, go look at an artichoke or an apple. I mean, we're talking about fruit here. Fruit can boggle your mind in its simple beauty, but yet its complex design. If we go on, I can talk about the purple mountains outside. I can talk about the stalagmites and the stalactites in the caves, or peacocks or sea urchins, so anything I've mentioned in this speech. No, we are not here by chance. As it says in Psalm 139:14, I praise you because I am fearfully and wonderfully made. Your works are wonderful. God designed us with mathematical sentences, with geometrical patterns. God designed us not just here by chance. It's not just a random assembly of molecules. No. And if God cares for the sparrow and won't let one fall without his asking, just a tiny little bird, and he adorns the lilies of the field with such beauty, my question to you, how much greater will he care for those who are made in his image?